In this video, we're going to look at questions concerning kinetic energy and the mechanisms and structures unit. This is on page 9 of the course notes. Again, there's 5 questions about kinetic energy. Now, what we learn in the course is that kinetic energy, the form of the equation we normally use is this here. The EK, representing kinetic energy in joules, is equal to 1/2 times m, representing the mass in kilograms, multiplied by v, representing the velocity in meters per second, and v is squared in our calculations. And it's important not to forget about the square and the v both when we're calculating kinetic energy or when we define mass or velocity. What we're going to look at here is each of these 6 questions, and they'll all be involved in using this formula. Question 1 tells us that during a sheet making process, 50 kilogram ingots of metal are passed along rollers at a speed of 0.5 meters per second. Calculate the kinetic energy of each ingot. So in question 1, we're actually given the 2 pieces of information that each from the formula. We're told that an ingot has a mass of 50 kilograms, which is the correct units, and the speed, or the velocity, of 0.5 meters per second. So we have both things we need to use the formula above, and we have it in the units we require. So I can write down EK. I'll make that K into a clear subscript. EK is equal to 1/2 times m times v squared. And so that's equal to 1/2 times 50 times 0.5. And remember, the 0.5 is squared. This is important, otherwise we won't get the correct value in our calculation. So we'll work this out. Always best to check with a calculator, even when we're dealing with values which aren't too complicated. And putting that into the calculator, we'll get an answer of 6.25. And remember, our units for energy in the standard form of the equation are going to be in joules. That's question 1. Question 2, we're given a different problem to solve in the sense we've been asked to find something else. We're told the speed of a car is 50 meters per second, and we're told its kinetic energy is 500 kilojoules. And remember, we work in joules, so we'd convert this in the first instance to 500,000 joules. Before we perform any calculation, we'll always convert our units into joules, kilograms, and meters per second in a kinetic energy calculation. We can look at our formula here and see we've got kinetic energy equal to 1/2 times mass times velocity squared. But this time we've been asked to find the mass. So there's 2 ways when we encounter something like this in engineering to tackle the problem. The best way is to rearrange the formula to get a formula for mass and put our numbers in there, and that's the way that we're going to solve it in this video. But we could also solve it just by putting the numbers straight into the formula as it is, and then rearranging the numbers that we get out. And if that method works for you, it's not incorrect. But there'll be plenty of times in engineering where rearranging the formula is definitely going to make the most sense. So we'll do that here. So we want to find mass by itself. We want to take mass here and take all the stuff on the right hand side and get rid of it. We need to shift it over to the left so we can have mass by itself. So one of the first things I can see, I can multiply both sides of this equation by 2. I can do the same thing to both sides of a formula and it's still a valid formula. So if I multiply the left hand side by 2, I'll get 2 times the kinetic energy. If I multiply the right hand side by 2, well, 2 times 1/2 is 1, so I'm just left with mv squared. We can take a similar approach. We can divide both sides by v squared. So we have 2ek divided by v squared on the left, and we'll just have m on the right, because mv squared divided by v squared, or v squared divided by v squared is 1. We just get m times 1, which is m. And of course, I can always write this round the other way to say that m is equal to 2ek divided by v squared. And now we can put in the values. So we have 2 times ek. Our value for ek is 500,000. I'm going to divide that by v squared. That's 50 squared. And again, we'll solve this with our calculator. We want to make sure we're getting these right. And the answer that comes out here is 400. And remember, we're not working out energy this time, we're working out mass for units here per kilogram. And that's how we solve question 2, by first rearranging the formula and then putting in the values. In question 3, we're again being asked to do a couple of different things. One, we're being asked to find out the speed. And this time there are 2 masses in the question. So what's going on here? Well, so the girl of mass 50 kilograms is riding in her bicycle. And it's got kinetic energy 22.5 kilojoules, and the bicycle has a mass of 30 kilograms. It says calculate the speed of the girl and bicycle. So in a scenario like this, we want to get the mass by adding the 2 masses together, because the kinetic energy applies to the whole system of the girl and the bicycle. So it's the mass of the whole system we're interested in. So 50 plus 30 is equal to 80 kilograms. And we're also told the energy of the system is 2.5 kilojoules, and as I mentioned, we can fit this into joules. So we need to find the velocity. Now, the equation for velocity is a little bit more work to do to find it than mass, but we can follow the same steps. EK is equal to half mv squared, and I'll do a couple of similar things than I did in question 2. I'll multiply both sides by 2 again to get rid of that half from the right hand side. I want to find v this time, so rather than dividing by v squared, I'll be dividing by m. This gives us a formula for v squared, but we want a formula for just v. And so the extra step that's required is we need to take the square root of both sides. Now, if we take the square root of v squared, we're going to get v. That's the definition of what it means to take a square root. That means on the other side, we have to take the square root of the whole side, so that's 2ek over m, and that's what's going to be equal to v. And that's before I can swap my equation around. I can always do that in any equation, just to write the left-hand side and the right and the left. And then we take the values and put them in. So I'm going to have 2 times 2,500, that's our value for ek, divided by 80. And when I work out that fraction, I'm going to take the square root of it as well. So in our calculators, we can start off by putting in square root, and then we can do 2 times 2,500 divided by 80. And when we work that out, the answer that we get, and we'll do this to a couple of decimal places, is 7.91 meters per second. And again, the units are very important here. So that's question 3. So let's now look at question 4. In question 4, we're told that the crane raises a load of 200 kilograms to a height of 30 meters in 1 minute at uniform speed. Determine the kinetic energy of the load when it is moving. So this question's a little bit trickier. It's asking us to do something a bit different. It's not giving us a velocity, but it's told us that information about the velocity that we can work out. But let's start right by doing the easy thing. So we know that the load is 200 kilograms, and we can write that down. We know we're asked to find the kinetic energies, but how do we find the velocity? Well, we know that it travels 30 meters in 1 minute, so that means it's going at a velocity of 30 meters a minute. And we could write that down. We could convert that unit into meters per second. With 30 meters in 1 minute, then it must be going in half a meter in every second. If you think about this for a second, our velocity is 30 meters per minute, and a second is 1/60th of a minute. So whatever I can do in 1 minute, I can do 1/60th of that in a second. So this would be the same as saying 30 divided by 60 meters per second. That's how we could work that out, to work it out, 0.5 meters per second. Of course, if you are quite happy using the formula for speed, distance, and time, you may have seen this before, that velocity is equal to distance divided by time. And of course, that's exactly what we have here, 30 being divided by 60. Same thing going on. If we change that minute to 60 seconds, then we have a velocity, distance, time calculation. But however you spot it, that velocity must be 0.5 meters per second. That is what our velocity is. And then it becomes a more straightforward calculation. We have our formula for kinetic energy, and we put in the values: a half times our mass of 200, which we're given in the question, times our velocity of 0.5, and we square that, which we worked out in just a moment ago. And when we put that all in, we get 25 joules as our answer. One final question in this part of the course on kinetic energy. And we look at question 5. An escalator has 6 people on it with a total mass of 900 kilograms. If the escalator moves at a uniform speed of 0.5 meters per second, what is the average amount of kinetic energy that each person contains? So we've got to be careful what we're going to ask for here. So it's saying that the total mass of the 6 people is 900 kilograms. So there's 2 ways to work this out. We could work out what the total kinetic energy of 6 people was, or we can realize that if we want to take the average mass, it's going to be 900 divided by 6. So we have 6 people weighing 900 in total, and the average, one of them weighs 6, and dividing that through, what we're going to see, that's 150 kilograms. So we base our question on a mass of 150 kilograms. And I'll just state that here, mass is equal to 150 kilograms. Because the elevator is moving at 0.5 meters per second, that means each person is moving at 0.5 meters per second as well. And so we have a mass and we have velocity. And so we can calculate the average amount of kinetic energy based on the average mass of each person. A half times 150 times 0.5 squared, and again calculate this, and it gives us an answer of 18.75 joules. And that concludes the questions on kinetic energy from the course.